we need more effort because people are going in different directions, and so you need to manage the people, and we could not do it, or we should not do it using equipment or sensors because they may mix up between the directions. So normally on intersection, as we have discussed for the delay yesterday as well, we count the vehicles as they leave the stop line if they're going straight, or if they reach the other side if they are taking a turn. So this is called as departure volume. But if you meet one of these conditions, then we call it a queue buildup, which means traffic is more than the capacity of the intersection, and then in that case departure volume is no longer a good measure for the actual volume on the intersection, because most of the people are stuck in the queue. So I want that count basically. Okay, people who have arrived and they got stuck in the queue. This will give you a uh, better idea of the actual demand of the intersection, the actual volume of the intersection. But the problem with the queue is, if you meet any of these conditions, that people are taking queue is getting longer and people are taking more than one green time to clear the intersection, then you need to focus on the arrival volume, not on the departure volume. Now the problem, and this is where we stopped last time, the problem with the departure volume is, the problem with the arrival volume is, departure is very simple. Departure means they are leaving. So I stand at the end of the intersection, I see them leave, I count them, no problem. Arrival volume is more complicated, because where are they arriving? They are arriving at the end of the queue, and the queue itself is dynamic. Queue is not something fixed. So queue is not always 2 vehicles. Sometimes it will be 10 vehicles, sometimes it will be 30 vehicles, sometimes it will be only 1 vehicle. So if there's something dynamic and you have to chase after it, you are looking at the back side of the queue. The back side of the queue is dynamic, it's moving forward and backward. The signal turns green, queue moves forward. Signal becomes red, queue is moving backward. So you don't have a fixed observation point in this case. So I need arrival volume, but my observation point is not fixed. So what do? I try to get the arrival volume using some calculations. Okay, so these are the calculations we need to perform to get the arrival volume. VA means arrival volume. I is the time interval for which you are taking the volume. Okay, so I could be from 4 to 4:15, let's say. So arrival volume, now you can see I'm calculating it, I'm not observing it. What am I observing in the field? VDI. VDI means what? Departure volume, the same thing which we were doing earlier. The vehicles are leaving, I have a fixed point, either the stop line or the other side, and I see them leave, I count them. So I have a fixed observation point for departure guys. So this will give me VDI. So I is the same time interval. Then NQI. Now NQI is number of vehicles in the queue at the end of I. Only at the end time. Okay. And NQI minus 1 is number of vehicles in the queue at the end of time I minus 1, the previous time. So if I is 4 to 4:15, then I minus 1 is 3:45 to 4, the previous 15 minutes. Okay. If I is 4 to 5, then I minus 1 is 3 to 4. Okay. So N, either I or NQI or I minus 1, belongs to the end part of the time interval. Okay. So this equation gives you the departure, the arrival volume. So we are not taking the Q for the whole time interval, NQ for the whole time interval. No, it's just a number at the end. Okay, so I do my whole time at the fixed observation point of the stop line or the other side, and then when the time finishes, I just look one time at the queue. So one time count of the queue is very easy. Okay, because I'm just doing it one time, and then for the next full time interval I'm not looking at the queue. Okay, so this is how I make my life easy and I still get the required arrival volume. But this is again if you meet one of these conditions. Okay, the normal one is you need VDI, that's it. Okay, this is an example where the arrival volume has to be calculated. So we are already assuming that those conditions are met. I need arrival volume. Okay, so how to do it? You can see I is every 15 minutes. This is shown in the first column. For every 15 minutes, you have VDI, departure count, VDI. And then you have the NQ, which is the queue length. And I told you queue length is only at the end. So when you see the first number is 0, that doesn't mean queue was 0 from 4 to 15. Queue is 0 at 4:15. Okay, only at 4:15. Maybe before 4:15 it was not 0. Okay, and after 4:15 it's not 0. We don't mind. At 4:15 when I looked at it, it was 0. So you see 0 here. Okay. Now my equation is this one. So I need departure plus number of vehicles queue now, number of vehicles queue previous. Departure plus number of vehicles in the queue now, so 50 plus 0. Number of vehicles in the queue before, nothing before, so I will assume 0. Okay, no queue count given for before, so I will assume 0. 50 plus 0 minus 0 is 50. Okay, so for the first time slot, it is 50 plus 0 minus 0. Okay, plus 0 for this count and minus 0 assumed for the previous count because I don't have it. Okay, so my arrival is 50 here. Okay, now if you look at this second case, 4:15 to 4:30, same will happen. But in this case, the previous 0 is not assumed. It is actually 0. So 55 plus 0 minus 0. Okay, I actually have a 0 here. Okay, so again, no problem here. 55 plus 0 minus 0, no problem. Okay, done. Next count, 62 plus 5 minus 0. Okay, so 62 plus 5 minus 0. You get 67. So this is your VAI for this time interval, 4:30 to 4:45. So between 4:30 to 4:45, I have 67 vehicles arrived. Okay, arrived. Out of these 67, 5 are where? In the queue. Okay, 5 are still in the queue. So if I was just looking at departure count, I will miss these 5. Okay, then the next one, 65 plus 10 minus 5. 65 queue count now minus 5 queue count before. Okay, so plus 10 is 75, minus 5 is 70. Very good. So now 70 vehicles arrived. Okay, the count says 65 plus 10, which is 75. But out of 75, 5 were the previous queue count. So the actual count is now 70. Okay, and you do the same thing for the entire table. Okay, for the entire, for all the values. Okay. So can you give me the rest of the values? What will happen here? 60 plus 12 minus 10, how much? Just for the sake of record. So how much you get for the next one? 60 plus 12 minus 10. How much you get? Yes, I think so. Yes. Okay, the next one, 60 plus 5 minus 12, how much? 62 is the correct answer for the previous one. How much for this one? 60 plus 5 minus 12, how much? 53. Okay, 60 plus 5 minus 12. Okay, and then the next one, 62 plus 0 minus 5, 57. Okay, and the next one will be without calculation, how much? 55. Yeah, because you don't have 55 plus 0 minus 0. Okay, now if you add these values, all of them, okay, if I go back, I had 50. Okay, if you add the values starting from here, it was 50 plus 55. Okay, and the next one was 67. 67, then I had 70, then I had 62 plus 53 plus 57 plus 55. What is this? 70, where's 70? 70, then 62 plus 53, 57 and 55. Okay, 57 plus 55. Okay, and this should be equal to 469. Okay, why I'm saying 469? Because you already said it, obviously, but it should be 469 because the departure is 469. Okay, if now keep note it down carefully. If your initial Q is 0, the final Q is 0. Initial and final both are 0. Then summation of departure and summation of arrival will be equal. Okay, if your initial and final Q is 0, then sum of VDI equals sum of VAI. Okay, if you meet both conditions, initial Q 0 and the final is also 0. Okay, otherwise if any of these values is not 0, you will not meet this. Okay, so this is what you have to keep in mind. Any questions? Okay, so now we are talking about intersection counts, TMCs, turning movement counts, and you know, a very important type of intersection is a signal. On a signal, we have some special considerations. Okay, one of the consideration is signal timing is divided. So all movements will not happen simultaneously. So I can use less observers for more movements. I know straight from one side and straight from the other side, they will not happen at the same time. Okay, or straight from the north, straight in the north south and straight in the east west will not happen at the same time because they are conflicting. Okay, so I know it will happen in different times and there is no randomness here. Okay, unsignalized, you may have a gap and somebody may cross from the other side. On a signal, it doesn't matter whether there is a gap or not, the other guy will only move when the signal is green. Okay, so you can use less observers for more movements. But on a signal, you have the extra consideration of cycle time. The extra consideration of cycle time. What we mean by cycle time? Again, something we discussed in the delay studies as well. Time when the signal goes from red to yellow to green to yellow to red again. So start of red to the start of next red. This is cycle time. So now your counting time should be such that the cycle time should be a multiple of that. The cycle time should be a multiple of your counting time. So if signal takes 1 minute to complete the cycle, then your counting time should be in minutes. You cannot have 1.5 minutes. Okay, and if you are doing it manually, then we know there are breaks as well. Okay, so in this case you have to make sure the break time is also multiple so that you have the total as multiple. So for example, your signal is taking 1 minute, you tell the observer, okay, you count for 5 minutes. Okay, so cycle 1 minute is a multiple of 5, so no problem. But then you tell the observer, now you take a break for 30 seconds. So 5 minutes plus 30 seconds, this is 5.5 minutes. Okay, so this is not the cycle length is not multiple of 5.5, so you cannot do this. Okay, so on a signal you can use less observers, but you have to assign the time according to the multiple of cycle lengths. Okay, all the times, whether they are for counting or whether they are for break. So eventually you get the full time as a multiple of cycle length. Why this is important? Because on a signal you may have a side which has more volume. So when signal completes one cycle, it gives the assigned time to all the movements. So if a movement needs more time, it will show with more volume. Okay, movement had more volume, it will show with more time, whatever you say, however you say it. But if you broke the cycle length, you did not finish it. So that means you are finishing in the middle of the phase, middle of the movement. So from one side, you may be having 100 vehicles coming if you waited till the end of the cycle. But what you did, you only took the count for half of the green time because you did not do the multiple. So when you took the half, that means you are taking the count as half as well for that side. Okay, so you did not account for that side completely. Okay, so this is why we need the multiple. So every side will have its full time, full assigned green time. So that's why we do the full cycle length. Now there's an exception to this rule. There's an exception to all the rules in the world, by the way. Okay, whenever we say a rule, then there's an exception. Okay, so the exception to this rule is if you have an actuated signal. What do you mean by actuated signal? I don't remember if we discussed earlier or not, but actuated signal is the one which is connected to a sensor. So cycle timing is changing according to the sensor. Sensor says more volume, cycle time increases. Sensor says less volume, cycle time reduces. So if the cycle time is changing, how can I take a multiple? I don't know multiple of what. Okay. So then what we do in these actuated signals, there's an option, not an option, it's a necessary part of actuated signal that you have to fix the maximum cycle length. Okay, so signal can operate at any cycle length up to this value. It can be less or equal to this value. So we take that maximum value because this is fixed by the programmer. The programmer will tell me, okay, the maximum I have put is 2 minutes. So I will use these 2 minutes to take the multiple. Okay. Now the question can be, if I am taking the multiple of maximum cycle length, the actual cycle length may not be equal to maximum all the time. Okay. So what if I'm taking multiple of 2 minutes, but the actual cycle time is 1.5 minutes? Okay, so you took multiple of 2 minutes, let's say 6 minutes. Okay, or let's say 8 minutes, let's say. Okay, so this is multiple of 2, fine. But the actual cycle length with the sensor, because of the sensor, was 1.5 minutes. Okay, so now you have the same problem we were discussing earlier, that 1.5 minute means 7.5 minutes you will have complete cycles, and then you will have last 30 seconds which are part of a cycle. Okay, you did not finish the 1.5 minutes for the last cycle. Now the answer is that this is taken care of by the signal itself. In this time when you were observing, the signal was giving more time to the movement which was higher. So it was already compensating for your lack of not taking the actual cycle length. Okay, so you don't have to worry about it. Okay, in the actual timing, the signal is giving more time to the actual high volume by itself because of the sensor. Okay, so on actuated signals, we can take a maximum, the multiple of maximum cycle length, but where the cycle length is fixed, we should take the multiple of the cycle length we have. Okay, so there are two main considerations. First is the number of observers. Second is the cycle length. Okay. Do you guys have any questions regarding this? Okay, is this clear? Everything is clear? Okay. So let us move on. These are few ways of representing intersection volume counts. This is called an arrow diagram. Okay, and you can see the boxes are showing the numbers and the arrows are showing the direction. So if you sum the numbers from all the arrows, you will get 415 here. So 30 from here and 10 from here and 375 from here. Okay, and you can see the bigger boxes as well. So this one was total for 400, then this was divided into 30 right, 300 straight and 70 left. Okay, so this is how you read it. Another way of representing intersection counts, which is using this what do you call it, intersection flow diagram. Okay, so now you don't see the boxes here, you see arrowheads and arrow tails. Arrowhead means it is going in this direction, arrow tail means it is coming out from here. Okay, and with every head and tail you see the lines with numbers, so they are showing you the movement. So 5979 total, 266 go here, 5540 go here, and 173 go here. Okay, similarly 7387 total, 1201 from here, 5540 from here, and 646 from here. Okay, the good thing about this diagram is the scaling of the arrowheads and tails. So the arrowheads and tails are not drawn at random sizes, they are in proportion to their volume. So this one is smaller than this one. Okay, and this one is smaller than this one. Okay, because of the volume. So 6000 is less, 8000 is more. So that means this one is smaller, this one is bigger. Okay, all of them are very close to each other, so you may not feel the difference, but they are the difference. This is how they do it in Bahrain. So usually they focus on 3 peak hours in the day, the morning and the evening and the afternoon. Okay, you can see the timing. This is for one particular intersection. Okay, so all intersection may not have the same peak timings. Okay, so you see the date. This is the code they give to the intersection or the count, the day and the date. Then you see the name of the highways written. Okay, you see color coding for different hours. The hours are mentioned here. And then you see different movements, okay, in different colors for different timings. Okay, and so this is, once you collect the volume, you can represent it like this. Now we move on to network studies. Okay, so up till now we were talking about single locations, one segment, one intersection. Now I'll talk about how to coordinate for the entire network. We need to coordinate. Okay, it's not like randomly you go, I'll go there today, I'll go there tomorrow, I'll go there for 1 hour, I'll go there for that to that place for 2 hours. No. In network studies, we coordinate the count for the entire network. How much time, what will be the break, what we will do after the count, this must be coordinated. Okay, so we do limited network studies for road networks around major traffic generators. Okay, major traffic generators, facilities which attract lot of traffic, facilities or buildings or projects which attract a lot of traffic. Can you give me example of a major traffic generator? What type of building can generate a lot of traffic or does generate a lot of traffic? Yes, anyone. Give me an example of a major traffic generator. Industrial buildings, okay. Anything else? Any other type of building you can think about which generates a very Large scale infrastructure doesn't generate traffic. Infrastructure doesn't generate. Yes. Airports, yes. Universities, yes. Okay. Infrastructure itself is serving the projects. It's not generating traffic itself. So yes, now you have the idea. Okay. Educational facilities, yes. Okay. So you have the idea now. Moving on. So a road network which is around these facilities, we coordinate our accounting study so that we can see the effect of the facility. Okay, how much is the effect of this facility on the network? Okay, so this is why we do the limited network study. Now, even around a small facility, you can have a lot of road segments and intersections. So doing the count for the entire intersection for the full required time is almost impossible. You will need a lot of people, you will need a lot of resources. Okay, imagine around one university, you may have 50, 60 intersections and you may have maybe 100, 120 segments. Okay, so whether you do it manually or sensors, equipment, whatever you do, you will need a lot of them. Okay, you will need a lot of effort. So what we need to do is we need to do some sampling. We don't take full count for the entire network. We do a sampling for the network. So now you are taking a sample. Okay, you are not taking the full count, but in the end you need the full count. Getting my point? I cannot collect the full count, but I need it. Okay, the same thing the same dilemma which we had for the arrival volume. I cannot count arrival volume, but in the end I need it. So I have to do some calculations to get what I need from the things which I have. Same thing happens here. You collect a sample for this limited network, then you apply some statistical calculations to get the entire count which you need. Now, when you are creating a sample, these are general assumptions which you have. Okay, and they apply to the counting study as well. The most important assumption of the sample is that what the sample is showing is the same as what you can expect in the full count as well. So if the sample shows the count is going up in the first 4 hours, this is what is happening in the network as well. Okay, so and if you see the count is very low in the last hour, so this is what I will expect in the rest of the network as well. Okay, now the problem is that in a road network all roads are not similar. Okay, one is a local street, the other one is a highway. Okay, one is a signalized intersection, the other one is a roundabout. So they don't behave in the same manner, their traffic is not the same. So when you are trying to make this assumption for different types of road together combined, then this assumption cannot be true. What you are assuming for a local street cannot be assumed for a major road, for a highway. Okay, so and what you are assuming for a residential area cannot be true for a commercial area. So that means before I start collecting my samples, I have to go and find out the parts of the network which can actually fulfill this assumption. The parts of the network which I can reasonably assume that they are similar to each other. So I can say highway will be similar to a highway. I can say residential will be similar to residential. Okay, but in my node network, I may have all of them. Okay, I may have a residential part, I may have a commercial part, I may have some segments which are highways, some segments which are local streets. Okay, so we call them what is written here, sub portions. Okay, sub portions which you can identify as they are same. Okay, so the portions of the network which you can consider that they are same as each other. The first thing is, before you start your sampling, you have to identify the parts of the network on which you can fulfill this assumption that anything which is happening on one part is same as the other parts. Then you in one part, in one sub portion, you will take two types of counts. Okay, if you have three sub portions in your network, you will take these two types of counts in each one of them. So they are called as coverage counts and control counts. Control count is the one which is full. Okay, so you select locations in your subnetwork on which you will do full counting. Full counting meaning the counting for the full required time period. If my required time period is 1 day, the control count will be 1 day. If my required count is 8 hours, the control count will be 8 hours. And the coverage count is a part of the full period. Coverage count is a part of the full period. So you will collect these two types of counts. In each subnetwork, you will identify locations on which you will do either a control count or the coverage count. Okay, so I have 10 locations in subnetwork 1, subportion 1. So out of these 10 locations, I may select 1 or 2 for full and the remaining 8 or 9 for coverage. Okay, so coverage is easier because you are not taking full. So you will do it on more locations. Okay, the easier thing on more locations. Control is heavy, it requires more effort, full time. So I'll do it on very few locations. Okay, but it should be within the same network, same subportion. Okay, so and each subportion you have to do both. You cannot say, okay, on highways I will only do control, on local street I will only do coverage. No, on highways, on the portion of the highways, you have to do both. Okay, some guidelines, because now you have to select these locations and their number, how many for control count and how many for coverage count. So they have given us some rules. The first rule is the ratio between control and coverage should not be very large. What is defined as large? Anything more than 20 is considered as large. Okay, anything less than 20 is considered as normal. Okay, less than 10 is very good. If you can somehow manage to be around 10 or less than 10, it is very good. Ratio means what? Like I give you the example, I have total 10 locations. Out of 10 I selected 1 for control and I selected the remaining 9 for coverage. So the ratio became 1:9 or 9:1. This is good because I am even less than 10. Okay, let's say I have another sub portion in which I have 40 locations. Okay, and I said in those 40 locations, like I did for the last one, I'll only take 1 for control and the remaining 39 for coverage. Now the ratio is 1:39 or 39:1. This is way beyond 20. Okay, so this is not good. Okay, so I should select few more locations to bring the ratio to less than 20. Okay, so this is the first guideline. The second one I already mentioned, that you need to identify subportions on the type of highway, based on the type of highway as well as based on the type of area. Okay, so don't mix residential area with commercial area, don't mix local street with highways and so on and so forth. And all counting is done at midpoints. Now remember, we are dealing with a network. Okay, we are dealing with a network, so you cannot if you include intersections, then at each intersection you have 12-16 movements, but on a mid block, on the road segment, you have only 2 movements. Okay, so mid blocks are easier. So that's why for control, for network studies, we only focus on mid blocks. Okay, so network studies are only done at mid blocks, meaning only done at segments. Only done at segments. Okay, so intersections are not included. And if another thing is, I don't know if it is written or not. Yes, it's written. So all intersections are excluded and all segments are included. So if you have 40 segments, I have to include all 40 of them in my study. If I have 30 intersections, I will not include any of these 30 in my study. Okay, so you cannot leave any segment and you cannot include any intersection. And the reason is simple. We are just trying to minimize our work as much as possible. Now let's say you are not including intersections, but the client after the project is done is asking for you for an intersection count. Okay, now this can be calculated for the client. Okay, how? So you have this intersection. You didn't do the count at the intersection, but you did on all the segments. So you have the count from all sides separately. If the client is asking for the intersection, I will tell him this is the total count of the intersection. Okay, so you have an estimate. This is not an accurate count of the intersection because you don't have every movement, but this is good enough with the amount of effort we are making. Okay, we are covering a huge covering a huge network with minimum effort. Okay, so this is the point here. Okay, so for example, if my this is for Isa town, so let's say this is my location, the traffic generator. Okay, so I have some main highways here. Okay, one is here as well. Okay, I have some local streets here within the area. Okay, I have this area is educational, this area is commercial, this area is residential. Okay, so these will become different sub portions. Okay, so I will take a different sample here, control and coverage, a different here and different one here, and so on and so forth. Okay, so you don't mix them. Okay, now let us move on to one example. What you see in front of you is a sub portion of the network, and the counting is required for 8 hours on all the segments. So if you see, the segments are numbered. You see 6 numbers here, and then you see another one in the middle which is A. Okay, so total 7. 6 segments are numbered, and then there is a 7th one which is A. So the numbered ones are coverage. Okay, and A is control. Now who can tell me what was the difference between them? What was the difference between control and coverage? Yes, I shall explain it today. What is the difference between control and coverage? Control, you take full count, yes, and coverage you have a part of the count. Okay, so on location A, I will take 8 hours. I need 8 hours. Remember, see in the question it is written 12 to 8. So 12 to 8 means 8 hours. While in the coverage, I will take part of the 8 hours. Okay, 1 hour, 2 hour. Okay, you will see in different examples. We are going to use this in some different examples. Okay, so all of them will not be the same hours, but all of them will have the same 8 hours for the control. Okay, so the coverage is part of these 8 hours in this example. We only need it for a typical weekday, our typical weekday, meaning 1. Okay, so 1 day, 8 hours. I need the count for all locations. As I said, control means full count. So on our typical weekday, I'll take full count at control point A. Now the problem is I have limited resources. The resources are limited in a way that that you only have 2 teams. So you can, in one time, you can only do recording at 2 locations. Okay, so one of those locations is point A. Okay, one of those locations is point A, but the other locations we have to manage with the same team. Okay, so we have total of 2 teams. One of them is busy on location A, and the other team has to switch from one point to the other. Okay. uh, so now let us see what they have done actually. Now in this table you see the count which is taken. Okay, so you have a count which is taken from 12 to 8 in the first 2 columns at location A. Now the other team which was switching from one location to the other, it was taking 1 hour count at the other locations. The remaining locations were 6, and the other team had 8 hours to count those 6 locations. So they decided, okay, we will spend 1 hour on each location. So within the 8 hours, we finalize the other 6 locations. Okay, the point is you have to do it within the remaining time, within their time. Okay, if you have some time remaining, 2 hours remaining, so they finished in 6 hours, they had total 8 hours, they can enjoy for 2 hours, no problem, nobody is stopping them. Okay, now at each location I need 8 hour count. At each location I need 8 hour count. So I will start with location A. So I need 8 hour count for location A. So I need a total of this one. So how much is the total of this thing? Okay, so the total 8 hour count at location A is 7067 vehicles. Now at location 1 and 2 and 3 up to 6, I have to use the 8 hour count of location A and find a factor so that I can convert the others into 8 hours as well. The others are 1 hour, right? I need 8 hours. So those factors are known as expansion factors. So expansion factor, in this example, you will take the hour count. Expansion factor means the hour count divided by the 8 hour count. Okay, in this example. But you keep the ratio in mind. It's a ratio. It's a ratio of the time you have upon the total. Okay, upon the total. So the hour count, let's say for the first hour, the hour count is 825 and the total is 7067. Okay, so for 12 to 1, the expansion factor will be count is 825 and the total is 7067. Okay, so how much is this? Okay, 0.117. Okay, for the next hour 1 to 2, expansion factor, it will be the hour count 811 upon the same total. Okay, then the next hour you have 912 upon 7067. How much? Okay, next one. Okay, so we are just changing the hour count. The total remains the same. Okay, next one. $149. Okay, then 163. Okay, the last one, 728. Okay, so I have the expansion factors. Now I shift my attention to the coverage counts. Okay, now the first coverage count is 840 and it is taken between 12 to 1 on location 1. Now 840 is the hour count, right? And I need the 8 hour count. So you remember the equation. What was the equation for expansion factor? Hour count upon total gives you the expansion factor. Now you have the expansion factor and you have the hour count. You need the total. Okay, so we'll use the same equation. Location 1, the time is 12 to 1. Okay, the expansion factor for this time is 0.117. So the 8-hour count will be the count we have already for 1 hour, 840, divided by the expansion factor. Okay, so this will give me the 8-hour count for location 1. How much is that? 7179. Okay, location 2, the count is taken between 1 to 2. Okay, so the count is 625. The expansion factor for 1 to 2 is 0.115. Okay, so how much will be the 8-hour count? 5435. Okay, location 3, 2 to 3. You use the expansion factor of 2 to 3. Okay, 0.129. How much is that? 4651. Location 4. Location 4 is between 4 to 5. Okay, 4 to 5. The expansion factor 0.149. So 826. Location 5. How much? Location 5 is between 5 to 6. Yes, location 5. Location 5 is between 5 to 6. The count is 1215 and the expansion factor is 1163. 2617. Last location 6. The count is 1440. The expansion factor 627 is 0.133. Okay, 7454. Okay, so these are the counts now. Now let's say the client is also asking for the peak hour count at each of the location. Okay, the peak hour count at each of the location. If I go and look at location A data, I can see the peak hour is between 5 to 6. Okay, the maximum count is between 5 to 6. So I know the peak hour is 5 to 6. The peak hour count at location A, peak hour volume at A is whatever you have, 1153. Okay, I want peak hour volume at location 1. Okay, now I know peak hour is between 5 to 6 from location A. It is between 5 to 6. Okay. Did I take the 5 to 6 count at location 1? No. Did I calculate it here? No. I calculated the full 8-hour count. So now I have full 8-hour count, which was 7179. I know if there was a count between 5 to 6, its expansion factor would be 0.163. So I don't have the count, but I have the full, and I know the expansion factor if I had taken the count at that location. Okay, so this will give me peak hour volume at this location. So how much is that? Okay, and the same will happen at location 2 as well. Okay, I will take the total of 2, which is 5435, and multiply with the same factor because all locations have the same peak hour. Remember, it's the same sub portion of the network. Okay, so for all locations you will multiply with the expansion factor of 5 to 6. 5 to 6 is the peak hour. How much is that? 886. Okay, at 3, how much? Total is 4651. So how much is this? 758. At the fourth location, how much? Okay, 412. Then location 5. You will just take the numbers from here, okay, and multiply with 0.163. So location 5 is how much? 427. What are you doing? You have to multiply the total with 0.163. I believe even this one has a mistake then. Location 4, 2826 multiplied by 0.163, and this one, you see, location 5 is already between 5 to 6. Okay, so you should get 1215. We will be doing this 2617. Either these values are not correct, there's a problem here, or whatever. But location 5, you already know the peak hour count is taken. Location 5, I should get 1215. And at location 6, because now you are making mistakes. So location 6 is 7454 multiplied by 0.163. So how much is this? Okay, what about location 6? I'm asking for this one, the last one. Yes. What about the last one? 7454 into 0.163. How much is that? Location 6 is 10827. Okay. 10827. Okay. How much is that? So you need to correct what we calculated earlier, but the point is you need to keep the, you need to understand the procedure. This is just for the sake of record. Okay, 1765. Okay, any questions regarding the procedure? You can correct the mistakes later on. Do you have any any questions in the procedure? Okay. Uh, what is this? Same, right? Okay, now we are doing on the same network another study, but this study involves multiple days because in the end I need average data. Okay, so that I should cover different variations of different days in my data. Okay, so when you collect one day of data, you don't have any account of variations of other days in your data. But when you collect data on multiple days, then your data shows how it will change in different days. Okay, so if you have multiple values, then you can merge them into an average. So this is what they have done. They had 6 locations. On each location they are taking 8-hour count now on each day. They still have the same 2 teams, the poor guys, and they on the coverage location, since they have 6 locations, so they are covering the 6 locations in 6 days. Okay, so that means they are spending those 6 days on the control location as well. Okay, so these timings should match. Okay, they can cover it in 5 days as well. Okay, but the problem is they cannot cover 5 locations in 5 days for the coverage. Okay, so that's why they are doing the full 6 locations here. Okay, so or for 6 days here. So in a, remember we are doing it on only on weekdays. Okay, so that's why you see the Monday to here. So you start from Monday, you go up to Friday, the weekdays are over. In obviously in US, uh, then you have to wait for the next week to start with the next weekday. So that's why you see 2 Mondays here. Okay, so like I said, now the problem has changed. I don't need a single value, I need an average value. Okay, single values for each location is already there. So on location A you have 6 single values, so I will calculate their average. So what is the average count at location A? What is the average of this thing? Yes, what is the average for location A here? Okay, so this is the average for location A. Now for the other locations, I cannot calculate average because location 1, only one count. So with one, you should not calculate average. I know you guys can, okay, or you guys want to, but you cannot, okay? So keep this in mind. So, okay, good, very good. Uh, So how do I calculate the average for location 1 and 2 with single values? So for that, we again go back to location A and we will calculate factors which are called as adjustment factors. So last time we were using expansion factors. Now we are using adjustment factors. Okay, so how do we calculate the adjustment factor? Adjustment factor equals the daily count, okay, upon the average. So if I'm doing it for uh, Monday 1, it will be the daily count is 7,000 and the average is 7350. 7350, okay, which is 1.05. Okay, what about Tuesday? Which one is correct? Let me, okay, 0.95 should be the correct one. Okay, for Tuesday, 0.88. For Wednesday, 1.05. For Thursday, 1.16. Friday, yes, Friday 7,000 again, so 0.95. And then Monday 2, so 6300.7350.86. Okay, so these are the expansion factors. Now you want to use the expansion factors to calculate the average. Tuesday is 1.05. Yeah, Tuesday and Wednesday are 1.05. Yes, Tuesday and Wednesday both 1.05 should be. Because they are same. The count is same, right? 7700. Okay. Okay. So now going back to why we did it, I need the average for the other locations. So I will take the value, multiply with the adjustment factor on the day of the value. Okay. So the value is taken. I'm doing it for location 1. It is on Monday 1. So the value would be for Monday 1, the factor is 0.95 and I multiply with the value which is taken on Monday 1, 6500. Okay. No, you multiply 6175. Okay. Location 2, you have to multiply this value 6200 with the factor of Tuesday 1.05. How much is that? Remember, we are multiplying, not dividing. So 6200 multiplied by the factor of Tuesday. How much? 6510. Location 3, factor is still 1.05 and multiplied by 6000. 6300. Okay, location 4, 7100 and the factor is 1.16. 236. Location 5, I use the factor of Friday on this one, 7800. How much? 7410. And location 6, the last one, Monday 2, 5400. Remember Monday 2, not Monday 1. So 0.86. 4644. Okay, so I hope it's clear. The opposite, count upon the average. We are doing the count upon the average. Average is in the denominator. Okay. moving on, now we have a 3-day study. Okay, so instead of doing it on 6 days, they are doing it on 3 days. Okay, so they are not spending one full day on every location. Remember, they are doing 8 hours every day. Okay, 8 hours every day. So if they want to finish in 3 days, they have 6 coverage locations. So in one day they have to finish 2 locations, so they can cover 6 in 3 days. Okay, so what they have done is they finish, or they did the 3 hours for the coverage, sorry, for the control, the 3 days for the control, sorry, 3 days for the control, and for the remaining locations they did this. Okay, 6 locations, 4 hours on each, total for each day is 8, so 2 locations in one day, 3 days, all locations covered. Okay, now we still need the same thing, we need the average count, we need the average count of 3 days. Okay, now for location A, no problem, you have 3 values, still in 3 days you have 3 values, so I can do the average here. So what is the average of these 3 values, just the last 3 values? Okay, 7,000, 7,500 and 6,400. What's the average of that? Okay, now you can see, so this is the average, and using the average I'll calculate the adjustment factors again. But before I do that, uh, if I look at the other values, they are for 4 hours. Okay, so if I want to calculate the average for these locations as well, I will calculate the average of 8-hour counts, not 4-hour counts. Okay, so first thing is I need to convert this 4 hours into 8 hours. Okay, so like we did in the first example, we converted 1 hour to 8 hours. Remember, we converted 1 hour to 8 hours. We do the same thing here, we'll convert 4 hours to 8 hours. So I need expansion factor, but those expansion factors were for each hour. These expansion factors will be for 4 hours because the count is taken for 4 hours. Now if you remember, the expansion factor was the hour count upon the total, which is basically the percentage of traffic, right? What we have in 1 hour upon the total, which is percentage. So they already did that. But instead of 1 hour, 4 hour upon the total. Okay, so 3,000 upon 7,000. So these are the expansion factors which are already given here. Okay, expansion factors are already given in the form of percentages. Okay, but these are for 4 hours because on these locations the count is taken for 4 hours. So I only need to calculate the adjustment factors using the average you gave me. Okay, so I have Monday has 7,000 divided by 6,967. How much is that? Remember, we are calculating the adjustment factor now. Expansion are already given. Almost 1, yes. Okay, for Tuesday, 7,500 divided by 6,967. How much? $1.1. And for Wednesday, I have 6,4 and 6,967. How much? Again, sure. 6,400 over 6,900. Okay. Okay. So these are the factors. Okay. Now I go to this one. Now I will start. I will do it for a couple of points, and then you can do for the rest. Now see, 2213, 4 hours. Which 4 hours? Monday 12 to 4. I go here. Monday 12 to 4. The expansion factor is 42.9, meaning 4.429%, or 0.429. So the count is 2213. So I'm doing location 1, Monday 12 to 4. Okay. The count is 2213. Divide by 0.429. This will convert it into 8 hours. Okay, and then I multiply with the adjustment factor like I did earlier. Okay, if I'm doing it for location 2, location 2 was Monday 4 to 8. The count is 3000. The expansion factor is 0.571 multiplied by 1. Both are Monday, so I'm using the expansion factor of Monday in both cases. Okay, for 3 and so on, you can do it. Any questions here? Okay, so I stop here.